So I think we covered, just for those of you who weren't here last time, we covered the first phase in every query processing, which is the evaluation of the from clause and all the different types of joins and how they are processed. Then whatever comes out of the from clause, no matter if it's 1,000 tables or a single table, gets moved to the next processing phase, which is the where clause. The where clause evaluates each row from the virtual set that was passed on from the from clause, and only rows where the predicate evaluates to true will get to move on to the next phase. Everything else is filter at that point. And we also discussed the different meanings of nulls, and Cod's original idea that he wanted to have two different types of nulls. And we also saw examples why that actually made a lot of sense, and it could have saved us a lot of grief and a lot of logical issues. But unfortunately, that's water under the bridge, and we have to deal with what we have now, which is a single null to represent both types of missing information. And our next stop is going to be the group by, and I'm sure you've all used group by many times before. Again, we're going to focus on the processing aspects, and I'm going to show you a few more interesting things about group by that maybe you didn't know before. Let's move on, and we go to the group by. So just a quick reminder, the database that I'm using is a database that I've created for my LinkedIn courses. I have a few courses on LinkedIn, and it's a database about an animal shelter. Whenever I'm going to introduce a table, I'll tell you a little bit about it. In this case, the animals table. First of all, for those of you who don't know, I'm a big advocate of using natural keys whenever possible, and hopefully with enough of these trainings going on, you'll start to see the benefits for yourself too. In this case, there's no animal ID or something like that. The key for the animals table is the name and the species of the animal. And the reason I did that is I tried to find a way that people at the shelter would really identify animals. And having volunteered in shelters for many years, this is one of the most common the shelter staff uses to identify individual animals. So we'll have April the rabbit, but we can also have April the dog, and Aria the dog, and Aria the cat, etc. As long as the combination of name and species is unique, that is what we use to identify the animal. And that's also the primary key of this table. You can download the script. Don't go to the animal shelter. This is the generic project. You're welcome to go in there, but that's not what I'm going to be using. I'm going to be using the one that I use for my LinkedIn courses, and that's going to be here. So there's two versions. There's one for PostgreSQL and one for SQL Server. What is the purpose of group by? What's the idea behind group by? Logically, not technically. Why do we need to group? Why do we need to group rows together, right? A relational database and relational tables, which represent relations in the real world, represent individual entities. So for the animals table, in this case, we're going to have a row for each individual animal. Each tuple or each row represents a real animal out there in the world. And that will be true no matter what kind of table we're dealing with. It's always going to be a relational table. A true relational table is going to represent a single entity in the real world. Up until now, both in the from and in the where, remember, the from evaluated all the table sources, created a virtual set. The where evaluated each row from the from, but we were at the granular level of details. Once we need to get higher level insights about our data, for example, if we want to find out how many animals we have in total, we're no longer interested in the individual animals. Now we're looking for a higher level insight about all our animals as a single group. So I'm sure you all know that to do that, all I got to do is say, select count star from animals, and that is going to return the number of animals. In this case, we have exactly 100 animals in the shelter. Well, 100 animals that have gone through the shelter. We'll see later that some of them have been adopted, and so they're no longer there. But overall, the animals table represents 100 animals that have passed through the shelter. The important thing to distinguish here is that as long as we looked at the individual rows, when I ran a select star from animals, I got 100 rows in return. My return set had the same number of rows as the number of rows in the animal table. When I change it to a count star, now I no longer get 100 rows, but I get a single row with a single result for the entire group. And remember that because that's going to be important. Another thing that most people don't realize that this is actually not legitimate SQL. The full SQL in this case is group by and open parentheses. And if I ran this, I don't know if you've ever tried it, but this is the correct syntax of SQL. Having aggregate on a table without a group by is just a shortcut that most databases provide. But if you want to write it correctly, this is the way that you should write it. And we'll go back to the empty parentheses in a minute. Well, another aspect of group by that I see a lot of experienced developers struggle with is the infamous error, which we're going to get. So for example, as long as I run a select star from animals, there's no problem. I'm going to get my 100 animals back. But once I add a group by, and let's say in this case, I want to group just by species. I want to be able to tell how many animals we have of each species. And let's just replace the star, let's say, with species and count star as number of animals. Straightforward, group by query, no problem. You can see we have cats, dogs, and rabbits, and the number of animals in each species. However, as a lot of you have experienced, I'm sure, if I add name to the select list and try to execute the same query, I'm going to get an error that states column animal's name is invalid in the select list because it's not contained in either an aggregate function or the group by clause. And my question to you is why? What's the logical reason behind this error? Apologies for the cat in the background. Anybody care to explain why? What this error, why do we get it? What does it mean? Why is name invalid in the select list in this case? What's the logical issue behind it that prevents SQL Server in this case? Yeah.
So when you do a group by, you're
Mm-hmm.
organizing it by that, and everything has to be a function. So you got to count the number of animals grouped by species, but your name isn't a function. So
Right.
your group
That's what.
by is in there, and aggregate functions, you can't have anything else.
Right. That's what the error states. I'm asking why. Why can't I have name? Why doesn't name make sense in this context?
Because it's not part of the grouping. What do you do with it? You're grouping by species.
Right.
So
So
there's no relevance to name in a group by species. If you want to, if name were a something you could apply a function against, where you would group by species, that would be fine. Or you could make name part of the group by, in which case then it could figure out how to use it, but it wouldn't make sense. I'm kind of lost as to the why. It sort of doesn't make sense to have name in there unless it's either part of the group by or part of a function.
okay, so let me run this query just without the group by, just the species and the name. And let's just for convenience sake, add a quick order by species. And I'm running half the query here, so pardon me. And let's look at the results. The reason is, and what I was looking for, and you were almost there, Fletcher, is the simple fact that there are many names per each species. And because the result of the group by, like we saw before, when you group by the entire table, I no longer get a row per each output row or a result row per each individual entity. Instead, I get one result row per group. And since name has many different values within the group, it doesn't make sense to ask for the details like the name, which can have many values, and the group at the same time. And that's the underlying reason. That's the logical reason behind this error. As you correctly stated, species makes sense in this context because species is guaranteed to have the same value for the entire group. This is what we used as the common denominator for the group. Therefore, it is guaranteed that for the entire group of cats, all the values in the species column will have the value cat. But that is not true for name, as obviously we can see, and that's exactly what the error complains about. I cannot show you a name when there are many multiple different ones. So you either add it to the group by, but now we're looking at a completely different query. Because if I group by species and name, which happens to be the key, now I get back to my original 100 table rows. Now I get a row for each unique animal, which is the combination of species and name. So it doesn't make sense. The only way for this to make sense is if I explicitly tell the database what name I want to pick from the group. And this is exactly the definition of an aggregate function. An aggregate function, by definition, operates on a set of elements and returns a single one. So count star is an aggregate function. It takes in all the rows and returns a single calculated value, which is the number of rows within the group. Minimum, for example, I can say something like minimum name. That's also a valid function because it will take all of the names and it will pick just one. In this case, if we're dealing with the default dictionary sort order, it's going to pick the name with the lowest dictionary sorting value. As you can see here, now we get Archie, Abby, and April all starting with an A, which is the lowest dictionary sort order. Now I want to show you some interesting behaviors of different databases, which not always behave the same way. If I take the same query, switch to a different database, in this case, I'm using SQLite. So here's the same query like before. You can see it's the same database, 30 cats, 60 dogs, and 10 rabbits. But here, if I add name and execute the query, anybody care to guess what's going to be the result? Anybody here ever work with SQLite? It actually returned, instead of getting an error telling me, hey, your query doesn't make sense because there are multiple names for each species, SQLite did not raise an error, and instead it returned a result. Anybody care to guess why Archie, Abby, and April were returned? Note, there's no minimum function on it, nothing.
I'm guessing it's the first record in each group.
Yeah,
The
that's what I
first
was thinking.
record. First record based on name?
Based on the species grouping.
What is the first record? What do you mean by the first record? The first record based on what? There's no order by. A set by definition has no order. By the way, let's try, instead of name, let's try something else, like primary color. Now you can see I still get some color. And by the way, that's not the first because we also have blacks. Believe it or not, when I first heard it years ago, I couldn't believe it. But if you go to the documentation, so SQLite actually thinks this is a feature. Bare columns and aggregate queries, the usual case is that all column names in an aggregate query are either arguments to an aggregate function or appear in the group by clause. However, a result column which contains a column name which is not within an aggregate function and does not appear in the group by clause, if one exists, is called a bare column. For example, select AB group by A. In the above query, the A column is part of the group by clause, blah, 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 blah. I want to get to the interesting part. And here it is. This is the highlight of this feature. The problem is that you usually do not know which input row is used to compute B, and in so many cases, the value for B is undefined. This means that SQLite just picks an arbitrary value. As far as you're concerned, it's a completely arbitrary value. So if you're working with SQLite, you should be very, very careful. Instead of raising an error, which is what it should do, lets you run the query and return some value. And if you don't notice it soon enough, you're going to have bugs. And you can imagine what this can lead to, right? Because every time this may return a different value. It's completely arbitrary. Even more interesting, and this I don't have an instance of MySQL, so I'm going to be using dbfiddle. So here we have the same animals table, and now I'm going to do group by species and name, and I'm going to add species name and count star as num animals. Let's run it. So far so good, right? No problem. Species and name is part of the group by, and count star, it's not a big deal because it's always going to return 1 because that's the key for the animals table. However, if I add primary color, and let's first take this, and SQL Server trying to run this is going to return the same error as before. Primary color is invalid in the select list. And if I try this in PostgreSQL, anyway, SQL Server returns an error. But if I run it here in MySQL, I don't get an error, even though if the group by is only by species, so note, I removed name from the group by and also from the select. And if I run this, I get the error. Number 2, expression number 2, primary color of the select list is not in the group by clause and contains non-aggregate column. Blah, blah. Let's go back here, reintroduce name, and here I'm going to add name, and here I'm going to add name as well, and I'm going to run both, and you'll see that the first one returns an error, but the second one, even though here too we have primary color, which is not part of the group by, we don't get an error, and MySQL actually returns a result set. Nobody? No guesses?
Is it because you grouped by what turned out to be the primary key?
That's the first part of the answer. Yes, but it's not the full answer. Can you be a little more specific?
Then it would know if it checked and saw that you were doing by the primary key, then it would know that each group contains only one row, and that there could be only one primary color.
Right. The correct technical term is actually listed here in front of you. It's called functional dependency. And functional dependency means that, in this case, the species and the name determines the primary color, because every animal can only have one primary color. Now, it's very obvious when we group by the key, because we know that's going to result in a single row. However, SQL Server, as you can see, in this case, doesn't care about that. And indeed, this is an optional feature of SQL that was introduced back in the days of SQL 99, which is called T301, if you are welcome to go and check it in the documentation, which allowed database vendors to implement this optional feature. It's not mandatory, but as you can see here, both Postgres and, by the way, I didn't realize that Postgres had it. It's interesting. You can see it also didn't return an error, even though if I remove name here, Postgres should return an error as well. Yes, okay. And MySQL implemented it. This will be true not only for primary keys. So even if you have a join between multiple tables and MySQL or Postgres are able to tell for sure that the attribute that you're trying to retrieve without an aggregate function is functionally dependent on the group by expressions, then it is perfectly legit to return that attribute because we know it's going to have one value per group. And that goes back to what I started with, which was the error that SQL Server gave us when we tried to retrieve the name. that I told you. Remember, the logical reason behind the fact that we cannot ask for name is that there are multiple names per group. But of course, that is not the case if we group by the key, or if the database, even if we have joins, the database is able to tell for sure that it is functionally dependent. Any questions so far? Another interesting aspect of group by, and that's also, remember I told you that when you run aggregate functions without a group by, what you're actually doing is grouping by an empty set. So the full syntax of the group by, which will work in this case, is this little nifty feature, which is called grouping sets. When we grouped by species and name, what we actually did was define a grouping set which consists of both attributes, species and name. And the full way to represent that as SQL is group by grouping set, species and name. Even though it's perfectly legal to write it like this, no problem. What happens if, in addition to the number of animals per species, I also want to be able to tell how many animals we have in total? We have 100 animals, right? We have 30 cats, 60 dogs, and 10 rabbits for a total of 100. What ways are you familiar with if I want in a single query to return not only the number of animals per species, but also the number of animals in total? And there are several ways to do that. Anybody want to suggest a way to do that?
Olga suggests Windows function or window function.
A window function is one way to do that. That is correct. Window function is a relatively new addition to SQL. And in order to do that, I think I did a session about window functions a couple of years ago.
Yep, that's
window
right.
function as total, let's call it total animals. And if I run this, oops, what did I get? Why did I get 3 and not 100?
Number of groupings?
Yes, that's the number of groupings. So the reason is, and again, I don't want to dive too deep into window functions, is that window functions, like every other expression, unlike these two functions, the count star and the count star over, are fundamentally different counts. This is a grouped aggregate, and this is a window aggregate. And the grouped aggregate has access to all the individual detail rows for each group of species. That's why it was able to count that we have 30 cats, 60 dogs, and 10 rabbits. However, the window function doesn't have that privilege. The window function can only see all the previous groups. And what it can count is the number of groups, which is 1, 2, 3, cats, dogs, and rabbits. So a window function is not going to help me here. Anybody care to suggest another idea? Maybe a different window function?
Could you use a union?
Another alternative is to use a union. And how would I do that? Let's copy this query and get rid of the window function. I'm going to get back to the window function in a minute because there is a way to do that with a window function. So the second way is to do select species group by species, union all, select, let's put the string all species, and count star from animals. And here, let's leave it without the group by. So now I have two separate queries, right? One, which will aggregate the entire table and will return the string all species with a count star. And if I take it and union it to the previous query, right, I'm going to get the result of both queries. Here we have, and the additional row that came from the second query. But that's a little bit cheating because we're accessing the same table twice. So if you look at the execution plan for this, you can see that the table was accessed twice. One with first the one what was a sort, that sort by species, and then the stream aggregate for the second one, and then both of them got concatenated here with a concatenation operator, and that gave us back the result that we were looking for here. But that's a legitimate way. That's a legit. Anybody care to suggest additional ideas of how to get this? Going back to the window function, I told you it is possible to do it with a window function, but it's not as straightforward as this. What you really need to do in order to get the total is what we need is not to count the number of rows or the number of row groups, which is going to be 3. What we actually need is to sum all the previous counts. We do it this way. So now we're not dealing with a count. The count star here is the same count star as above. The over clause, which makes it a window function, now refers to the sum. So the sum, which has access to all the other groups, is going to sum all the previous counts of all the others, and that's going to return the 100 that we were looking for, which is the sum of all these. This returns a column with the total number of animals for each and every row. And of course, because over clause is empty, meaning that every row which is evaluated in the select list is going to see the exact same set, the result is going to be the same. There's a little bit of redundancy here, as opposed to this method, which didn't return an additional column, but instead returned an additional row with the number for all species. Anybody familiar with another way to do that? By the way, nobody suggested a subquery. I was sure that was the first thing you're...
Actually, Olga did.
Okay, I'm sorry, I missed it. Window functions, subquery, not union CT. Okay, yes, correct. So another way is simply to add, let's add it here as another option. And we can do select count star from animals as total animals, and that's also going to return the total number of animals. A little bit of cheating because we're referencing the same table twice, so much like we're doing here. There is another way, which is much more efficient and much more clear and much more useful than all 3 of these, and this is by using grouping sets. So remember, I told you that you can write the same thing as grouping sets, and then in parentheses, place the sets that you're interested in. Parentheses, we can put the sets that we want to group by. If I put just the single column, this is the exact equivalent of the group by without the grouping sets. However, I can also add another element to the grouping sets and tell it, hey, I want the query grouped not only by species, but in addition, I also want you to create a super aggregate on top of the entire table by specifying empty parentheses. And if I run this, we get the results of the query that was grouped by species, which is this guy. And we also get an additional row with a total. Now, this is roughly the equivalent of what we did here with the union all. We're actually doing 2 different aggregates in a single query. The difference is that here I explicitly wrote all species. I put my own string. The database won't make that decision for me. So what I need to do in order to make it exactly the same is simply add is now and call it as species. And now, if I run this, now you can see. Anyway, we got the results for this grouping set, and then we got the result for the master grouping set, in this case, the super aggregate, which refers to the empty parentheses, which is the total. By the way, why is the last S missing? Triple bonus points to the person who, this is not an error.
It's because the initial field size was set to whatever the species size is, so the all special trim to match that size.
Correct. And how would you fix that?
You could do padding, you could do whatever you needed to make it so it would be large enough.
Let's try this. I just increased it, did a cast, and now we get the full string back. Triple bonus points to Fletcher. Okay, but things get even more interesting. So what happens if, let's take another table. enough with the animals table, vaccinations. This is the vaccination table. Every animal that was ever vaccinated. Now you can see we get the vaccine, the batch name, the email of the person. That's the identifier of the person, the email of the person who performed the vaccine. Anybody care to guess what the primary key of vaccinations would be?
The four first keys, the first four columns.
Yes, that would actually, it makes sense. The real key is actually the first three, because the vaccination time also has the time element to it. And my assumption was, but it's a good point that you, now that I think of it, maybe it should be the four, that you give each vaccine individually. So you cannot give two at the same time. And since we have the time element here, the key is actually these three: the name, species, and vaccination time. So let's say I want to see each animal, and I also want to see the latest vaccination that it received. How will I do that? I will go group by name, species, and now once I introduced group by, now I can only put name, species, and max vaccination time as latest vaccine. Every animal and the latest vaccine that it received. Now, if I want to add on top of that, I also want to see the total number of vaccinations for the entire. Let's see how many we have. Select count star from vaccinations. This is something that as I age, I make more and more. I don't know if it's just me, but I switch characters when I type. So we have 95 vaccinations in total. If I want to show how many vaccinations in total we have, how would you go about it? One way was to use a window function. Another way would be to use a union. But if I want to use a grouping set, now I have a problem. Because if I do something like grouping set name, species, and empty parentheses, what am I going to get? Let's run it and see if anybody can spot what's going on. What happened here? How come I have so many animals with null for species? I have the null, which we'll get into in a minute. I have name null and species, which is the latest vaccine for what? For each species. And if I scroll down,
Didn't
you'll
it
see that I
essentially
have,
do didn't it essentially do two groups by one? The first group was by species and the second one was by name.
correct. It actually did three. This is the equivalent of having three queries unioned together, one which groups by name, one which groups by species, and one which groups by the empty set, meaning the entire table is at one group. And that's one of the most confusing aspects of grouping sets. I still make errors when I write code that uses it. What you need to remember is that for a grouping element to be treated as a single grouping set, it has to be in parentheses as well. Grouping sets by name, species, and the empty set, this is what we wanted. And it's super confusing. And now you can see we no longer have nulls for species, except for the last row here, which is the latest vaccine, in this case, for all of the latest vaccine ever for all animals, right? So here I have the max. If I want to see the total count, then I need to add a count star as num vaccines. And this will work pretty much the same way until the last row, where you can see that we got the latest vaccine and the total number of vaccinations. So now we have the number of vaccinations per animal, and this is the result of this grouping set of name and species. Then we have the total. So here we have only two aggregates, one which groups by name and species as a single set, and one that groups by all. Even if I remove the all, and this is where it gets tricky, and this is where I see people fail over and over again, is the difference between this and this. Now, if you look at it, it looks almost the same. Everything else is the same. The only difference is one little set of parentheses. But that little set makes the whole difference. Let me put it in a new query so we can run it. And if I run this guy, I get one row per animal, which is a unique set of name and species. But the same thing, just with one less parentheses, is going to return. See how many rows? Here we have 48 rows. Here we have 46 rows. But now you can see we get also all the animals with null for species simply because this treats them as one which is grouped by name and another query which is grouped by species, not a single query that groups by both name and species. And by the way, if you want to be even more pedantic, the full syntax, this is also kind of a shortcut. The full syntax allows us to define multiple grouping sets separated by commas. Kind of makes it a little more clear, but pretty cool, huh? SQL is amazing. Oh, any questions about grouping sets? There's plenty of, it's fully documented. I know not many people are aware of this feature, but if you go to the SQL Server documentation, there's plenty of examples. It explains it. So I think that's enough for grouping. Now we can move on to the rest, unless anybody has any questions about grouping. Okay, moving on. So we already skipped a little bit. We discussed the select, and we saw that the select evaluated each expression for each and every row, unless we had a group by, in which case the select expression was evaluated for each row group, or we can call it for each group instead of for each row if it's more convenient. But between them, there's an additional clause, which is really simple. But here, too, there's a few misunderstandings about having. So let's clarify some of these as well. The having, and let's try a different table this time. So let's go and do select star from, and who wants to guess what's going to be the key of this table? By the way, did you notice that when I did because I used natural keys, because I used the name and the species also for the vaccination, I didn't need to join back to animals to see the animal, right? If I were to use animal ID or some other whatever meaningless surrogate, every query that has something to do with an animal would have to join back to the animals table to get the name. But by using the natural key, I avoid all these joins because the real identifier of the animal appears in each and every child table. Just a side comment. So who would care to guess what would be the key of adoptions?
My guess is name, species, and adopter email.
Okay, and what would that mean?
That particular pet was adopted by that particular person.
Correct, but that would also mean that the same pet could be adopted by multiple people. Because if your key is all of these three columns, then I can have Abby the dog adopted by Patrick, but also by Justin. Which
You have a point.
And it's not wrong. So if this is what you're trying to represent, it's perfectly legit, because some shelters, if an animal was adopted and 3 days later, I don't know, it didn't work out and the owner returned it, the adopter returned it, and then it was adopted again by another person, then we would have some modeling issues to discuss here, how to make sure that the animal is not adopted twice before it is returned, right? But that's a different topic. In this case, in my shelter, we are an ideal shelter when nobody returns animals. So the key here is actually name and species. And again, go to the GitHub link that I gave you. You can see the tables. Okay. So here we have name and species. Now let's say that I want to group by species again, which means that in the select, I can only have species. And let's say I want to find out the average adoption fee. What was the average adoption fee that was paid per species? Okay, let's execute this query and well, we can see that cats are more expensive than dogs and dogs are more expensive than rabbits. That's completely coincidental, by the way. The fees were generated randomly. Let's say that I want to add a filter where, say, year adoption date is 2018. And now I want to add another filter which will limit. I only want to see species where the average fee was larger than 70. So you all know that in order to do that, what I need to do is have the average adoption fee larger than 70, right? First, let's focus on the logical differences between these two predicates, between the where and the having. And remember, the focus here is order of execution. So the where took place after the from. That means that it had access to all the rows, whatever was evaluated in the from. In this case, it's just the adoption. Every row from adoption got evaluated by the predicate, whether the year is 2018. Then it was grouped by species. And after the group by, then comes the having clause, which also has a predicate, which is very similar to the where predicate. This is also a predicate that only, in this case, row groups that evaluate to true will get to pass on and live to see the select. What's important to realize, that's the only difference between the where and having is where they take place. There's no other difference. Both filter out their entire elements. In the where clause, it's individual rows, and the having, it's the grouping or the groups, but both use predicates and the logic is the same. It will be evaluated per row or per group, and only rows or groups that will evaluate to true will get to pass on to the next phase. If I try to be a smart ass and do something like this, and I'm going to execute this query, I'm going to get an error. An aggregate may not appear in the where clause unless it is blah, 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 unless it's a subquery. So, and now you know why. The reason that we cannot use aggregate is simply that at the point in time that the where clause gets evaluated, the grouping hasn't been done yet. Therefore, the average doesn't make sense. However, what about, let me copy this. What if I remove the whole thing? Is this the legitimate query?
I think it would be if you changed the average function in the where clause to just avg underscore fee.
Okay, so you're suggesting to use the alias here, right? You can already see we got a red squiggly line. Anybody want to tell who was it that suggested it?
That was me, Mark.
Mark. Okay, Mark. Anybody care to? So first of all, let's run it. An expression. Oh, sorry. We need to say average fee larger than 70. And if I run it, I get the error, invalid column name, average fee. Anybody care to guess why average fee?
In our order that you gave us, select is number 5, and we're only at having, which is number 4.
Absolutely correct. So the reason is that when the where is evaluated, the select clause hasn't been evaluated yet. And that also means that the aliases that were defined in the select are not known. And this is the correct behavior. What SQL Server is doing here is actually the correct behavior. However, if I take this and go back to MySQL, let's try this. We also get unknown column, average fee in where clause. By the way, what would happen if I would just say having? Would that make sense? Did you know that you can have having without a group by? And in this case, what's happened here? I just told you a second ago that the select list takes place after the having. So how come Unlike SQL Server, and by the way, if we take this and try to run it in SQL Server is still going to complain that the invalid column, the average fee is invalid. And that's for the exact same reason that we discussed, because SQL Server doesn't allow referencing expressions or aliases that have not yet been evaluated. However, MySQL and some other databases give you a discount here. They say, okay, yeah, this is not really legal, but I know what you mean. Because I know that you alias, I already read your entire query, and I know that with average fee, what you mean is average adoption fee. So even though it's not technically legal, I'm going to turn a blind eye and I'm going to let you use that. I highly recommend that you don't, simply because not all databases support it. What was interesting that you saw that when I put it in the where, it still complained that the average fee is unknown. And the reason is that it doesn't do this discount when you're egregiously wrong, like we are here, when we're trying to evaluate an aggregate when the grouping hasn't even taken place here. But if we go back here and say, so we understand why we cannot use the alias. But what about this? Is this a legitimate query? Perfectly legit. Remember why? When we started talking about group by, I told you that when you use an aggregate function and you don't have a group by, it's the same as if you're grouping by an empty set. Remember that? So you don't have to write this group by if you don't want to, but I think it makes things a little more interesting and more clear. And this you can understand why it's a legitimate query, right? I group by the entire set, and I'm only interested in groups where the adoption fee is larger than 70. Now, this doesn't make much sense because we only have one group, which is the average adoption fee of the entire table, which is 74. Even though logically it doesn't make much sense in terms of the data, in terms of the syntax and the query processing, it's a perfectly legitimate query. And in other cases, where you might have multiple queries or nested queries, or you use it within window function, it can actually sometimes be useful. Let's leave it at that. Another interesting fact about having that not a lot of people are aware, and even if you go online and you see, there's all these articles about SQL interview questions, and I'm dreaded when I see them on LinkedIn, because most of them, they give you interview question and they don't have a single correct answer there. The worst thing is that's what the interviewers are actually expecting to hear, because not a lot of people understand query processing and what SQL is really all about. Anyway, one of the things that I often hear, so when people are asked what's the difference between where and having, is that having can use aggregate functions and the where cannot. While we already saw this is to a certain degree correct, but let's remove this guy for a minute, and having species different than cat. What about this query? Is this a legitimate query?
Yeah, that should be legitimate.
What's going to happen if I run this query?
Cat
Nobody
comment.
cares to guess? The only difference between having and where is where they take place. Having takes place after the group by. But the group by expressions themselves, the same way that I can reference species in the select, which also happens after the group by, nothing prevents me from specifying it in the having. If I were to try and do something like having name, not like, I don't know, Bella, this is going to run into, see the error? Column name is invalid in the having clause because it's not contained in either an aggregate function or the group by clause. This is the exact same error that we got before when I tried to put name in the select list. But the only difference is that here it said it's invalid in the select list. And if I try to put it in the having clause, it's going to give me the error that says name is invalid in the having clause, but for the exact same reason. Because for every species, there are multiple names. Which one do you want me to compare to Bella? Having minimum name different than Bella, that's a valid query. Because here I'm picking a specific name out of the group of the species and comparing it to the string Bella. And this is legit, no problem. But going back to our original query, this is also a legitimate query. The same way that I can specify species in the select because it is guaranteed to have the same value for all rows within a group, I can use it for the filter. Technically, I wouldn't want to do that because there's really no reason to do that if I can do the same thing in the where clause. And why is that?
Because the where clause
What's
is
the benefit of filtering in the where versus filtering in the having? This is
the
the
where
exact same predicate.
the where is always going to be faster. The having deals with it comes in so late that it can't take advantage of indexes and other things, whereas the where is the most optimal way to do it.
Correct, Irina. Cuts will be excluded from the result, but they will be excluded from the result in both cases. They will be excluded if I put it in the where or if I put it in the having. What's the benefit of putting it in the where versus putting it in the having? It's just that it's more efficient to do so. Because if I eliminate it before the group by, that means that the group by, remember, the group by receives the set after the filter. That means that it doesn't have to group all the cats together only to eliminate them a second later. So if you want to filter by the group by expression, just for efficiency's sake, it makes more sense to do it in the where. But there is nothing that prevents you from doing it in the having. And as you can see, having doesn't necessarily have to use aggregate function. The only reason that we usually use aggregate function is for the same reason we use it in the select list, because anything other than the group by doesn't make sense in this context and is going to give you an error.
Has there been any?
Okay,
I had a quick question, if you don't mind.
any questions about having?
Yeah, I have a quick question, Ami.
So I'm hearing question. I don't know if you're
Don't
hearing
worry,
that
the rest
also,
are going
Ami.
to be much. Yes.
Yeah. So, and maybe I'm missing something obvious, but I'm just curious. Has there been any consideration for any of these vendors to allow you to write the statement such that it mirrors the execution order?
So this is an implementation detail, and the implementation detail can vary from one query to the other, from one vendor to the other, from one service pack to the other. So the execution plan, and I think something that I did want to show, and I think I didn't show it earlier, is that with grouping sets, if I look at the plan, you can see that the table is actually accessed only once. It's not accessed multiple times like it did with the union all. However, that's an implementation detail. The beauty of SQL is that it's a declarative language and it's completely independent of any physical implementation, neither of the query optimizer, neither the storage engine. It's purely declarative. And all I'm discussing in this session are the logical aspects. And logically, having the predicate species different than cat in the where versus having it in the having logically makes a difference. You know what? Let's see if SQL Server is smart enough to come up with the same execution plan for both. I can tell you for sure that MySQL won't, and most other databases won't, but SQL Server may. So let's give it a shot. Okay, so first of all, let's take a look at these two plans, see if SQL Server is smart enough to come up with the exact same plan, and it looks like it is. I wouldn't rely on it. First of all, because other databases might not be smart enough to realize that this is actually the same thing. Let's see how Postgres deals with these.
Well, I think my question was slightly different, though. And again, maybe I'm missing something obvious, and sorry if I am, but and I'm used to writing the queries in the sequence that you're showing them here. But now that I'm learning of the execution order, I'm inclined to think I'd rather write them such that the sequence conveys the execution order, because it would be more of a logical way for me to put it together. I'm just curious about whether that consideration has ever come up, or again, if I'm missing something, I'm completely missing the plot here, then just tell me.
This is logical. The database can make shortcuts and can push down, for example, if I have a filter in the group by or in the select or in the subquery, the query optimizer is a wizard at moving things around in order to make them more efficient. It has nothing to do with the logical order which we're discussing here.
Yeah, but what if the syntax, instead of starting with select, started with from?
Yeah, exactly. That's kind of
Yeah.
where.
Oh, I see what your question.
Yeah.
Well, that you gotta. There's Chamberlain and Boyce, the guys who developed the original SQL. You're more than welcome to ask them. By the way, there are query languages that actually start with a from.
Oh, okay. Okay.
Microsoft's Link does that.
Right, Link. That's the one. I forgot the name. Link. Yeah, Link actually starts with a from. Yeah, you cannot write. You cannot start with a from. You have to SQL. The syntax requires you to start with a select.
Okay.
Okay. We saw having. We saw. So I wanted to show a little bit about distinct, but I won't go into that. Distinct is also interesting because it's sort of a group by, but not really, because it takes place after the select. Yeah, maybe we'll do a future session about that. What I really want to talk about is order by. Order by is really interesting in the sense that the relational model has absolutely nothing to do with order. In fact, a relation, one of the properties of a relation, which the SQL counterpart is a table or a set, or the result of a table is, or result of a query, sorry, is one of the most fundamental attributes is that it has no order. And the developers the same Chamberlain and Boyce, and then later accepted by the ANSI SQL standard, allowed for order by. And I'm talking about order by for presentation purposes. So take whatever query. Let's get another query. Select star from animals, order by, species, and name. The order by is the only clause that happens after the select. By the way, that's why the order by can use aliases that are defined in the select. So for example, let's go back to one of the group bys that we had. Here, it will be perfectly legit, and even SQL Server will allow it. Order by, average fee. And again, the reason is that the order by takes place after the select. So now at this point, and of course, order by a single row doesn't really make much sense, but at least you can see that the query is legitimate. So even if I had here group by species, and we had here species and average fee, then it would make a little more sense to sort by the average fee because there's more than one. This is purely for presentation purposes. And if you think about it, in the general architecture of any N-tier application, there's a clear distribution of responsibilities, right? The data tier is responsible for storing, managing, and retrieving the data. The middle tier is responsible for enforcing business logic, which also many a times gets moved to the database, and that's a topic for a different session. And the responsibility for anything that has to do with presentation is the responsibility of the presentation tier. Now, it could be if you're using a web application, it will be in your web server code. If you're using a FAT client, then it will be the responsibility of the client to sort your rows. Now, in the same way that you don't expect SQL to do fonts and formats and colors and frames, why do you think it's the responsibility of SQL to sort rows for client presentation? It doesn't make any sense. And not only that, it causes so much grief because of numerous aspects of order by, for the first thing being that a lot of people use order by on non-unique columns or non-unique expressions, which makes the whole query non-deterministic. Meaning, if I order by average fee and I happen to have more than 2 rows with the same average fee, that means that if I run the query once, either of them can come first and it will still be a valid result. It gets even worse when you rely on the order by for things like offset fetch, which limit the number of rows. So offset 0 rows, fetch next 1 row. If we're ordering by an expression which is non-deterministic and the application relies on this and then says, okay, bring me the next batch, not only can you bring the same row to multiple pages, you can also miss entire rows altogether. Not only that, the fact that you're ordering in the database is a performance hit in so many cases that would have been orders of magnitude cheaper to just sort it in the client, especially for queries that potentially can return thousands, hundreds of thousands, or millions of rows. Because when you do this sorting in the database, you're going to sort by the entire query result. That means 1 million rows will get sorted. When in the client, rarely will you show 1 million rows on a page. So it could be orders of magnitude cheaper to do that where it belongs, which is the client's application. Well, I can do a whole session just on that, but I think we covered most of what I wanted to talk about. So thank you very much. I hope that you enjoyed today's session, and Mark, I'll hand it over to you.